we had before, except that we throw tension into it. Or, sorry, we throw the friction into it.
Wait, where did we get that?
It's the tension plus the friction force minus the mg sine 40 degrees. Y sub 5 from this equation here, add that over.
Yeah.
The look says that I probably should not have skipped that step. And
Oh, okay, so you sub the y sub 5, okay,
Yes.
that's what got me, I was confused.
For those who just haven't asked, but
Oh.
Y5 is equal to M5G cosine 40 degrees.
Right. Because it was weight 5, and weight 5 is just, yeah, 5.
So that is Y sub 5.
Okay, now, that confused me, thank you.
And then the other equation where there is no friction, that, we still don't care about that, but this is the equation we're working with here.
Cosine 40.
So M10G sine of 9.375 degrees. Minus tension is equal to M10A. And solve. We have two equations, two unknowns. I'm going to solve this slightly differently than we did before, where we solve for ft in one equation and plug into the other. We can save just a little bit of time if I just add the left sides and I add the right sides. Because I have a positive tension here, a negative tension here, they would cancel out when I add them. So I'm left with M10G sine of 9.375 degrees plus u sub s M5G cosine of 40 degrees minus M5G sine of 40 degrees equals M5A plus M10A.
And then that'd be 15A.
We know everything on the left-hand side, it's a plug and chug exercise.
Why is it 15A?
Because I have M5A plus M10A. I'm adding the right-hand sides.
Oh, yeah. Oh, so before when you said 15A, it was the same thing?
Yeah.
Okay.
So at the, on the top there, how did we go from M5A on the right side down to M10A on the right side?
Yeah, this first equation right here is this. All I did was substitute in for value for Y5. That second equation is this one.
Oh, it's different, okay.
Yeah.
Wait, where's FT go then? Is FT?
No, FT cancels.
I have positive tension here, I have negative tension, so when I add them, they
So you just
cancel.
add, okay. Yeah, I'm getting it. Yeah. Okay. I'm still not used to treating that like an addition problem, and I'm seeing them as two separate things you can't
And-
add together.
Which is one of the reasons I'm doing it. If
Yeah.
we had done that before, it would save us 2 steps.
Okay. Okay.
Gotcha.
Okay.
Alright, I will,
So now that we just plug
I'm
in.
gonna go ham real fast. Give me a sec.
I'm still
And
kind
somehow
of.
I magically erased some of this.
0.1.
Yeah, I was very confused here.
5, 10.
So there's no substitution going on with this.
No, no substitution, just.
5,
So how do we know to add those two
10.
formulas?
Well, I have two unknowns. I have tension and acceleration.
Uh-huh.
I'm starting to find acceleration, so getting rid of tension would be win. If I add them up, I have a positive tension and negative tension, they would cancel out if I just add them.
Okay.
I did everything like all at once, and I got the A is equal to negative 0.8013. 8013
I got that as well.
Units?
meters per second squared.
Newtons per kilogram.
that too. All right, you have a negative here. Is it moving?
No. Wait.
Yeah, it's
Yes.
moving in the
Yes.
opposite
Yeah, it's
direction.
using
Yes,
the
it's
opposite direction.
Of our, oh, so
It's opposite to what?
it did overcome it.
It did,
Our coordinate system.
yes. It's in the negative direction, which is what we knew it would do.
So,
So, negative, it is accelerating in the direction we expected.
okay.
Oh, not like that. Remember, eyes are pointed this way, so
Oh.
negative means it's going.
So it's, okay.
So that means this, even with the friction, the box is still moving.
Yes.
Yes, so it overcame the friction, which was the question, right? Would it overcome
That-
the,
Now that we
I
know
thought
it
the
has to
question-
overcome the static friction,
yeah.
that is not the answer.
I thought the question was
Oh.
limited acceleration.
It
I thought-
is.
Oh,
But that's not the answer.
Now
That's
we
not
have to
the-
plug in MK.
No.
Use of K.
This is-
This was working under the assumption that we were at the maximum static, but we've overcome that, so we're not at maximum static, we're at kinetic.
Oh, no.
Oh.
The advantage of not plugging in numbers until the end is that this equation doesn't change. The only thing that changes, well, contradicting myself, the only thing that changes is that S becomes a K.
Oh, so.
This is now a use of K. This is, or S of K, use of K. K.
What about the bottom one there? Okay.
So you're doing the same thing you did before, except now you're putting in 0.05 instead of 0.1.
Let me just make that change real fast.
Okay.
0.05.
So then what we're really trying to find is a muse of S
I got it.
where we don't overcome.
If we don't overcome it, then the acceleration is 0.
But is that what we're looking for? Like, is that what we want?
We want to know what the acceleration is.
Oh, okay. Like in general, what
Yeah.
is the acceleration?
What is the acceleration?
Okay.
I got it. Doing all of that.
So we got
Negative 0.92898 meters per second squared.
just a quick check here. I expect my acceleration to increase over this value we had with static. And I expect my acceleration to be less than the no friction scenario, which was 1.06
Yeah.
something.
Yeah.
So it is in between those, so there is some reassurance that we've done something right.
Something went well.
Maybe.
What?
We can just, you know, pat ourselves on the back and just assume that we're right, and if any points get marked off, it's because the grader was inferior to you and didn't understand your brilliance.
When we have this because we have, this specific I-hat direction, that's, the acceleration has to be negative.
Yes.
Okay.
Which is why I asked the previous part, so that you knew which way the acceleration would be in this situation. I broke it down first, come up with an angle, just showing you know something about equilibrium. Then let's change the angle so that it will accelerate and you know which direction it is. And then we throw friction into it, so at that point you know which way you'll know which way friction has to act.
So that, the big equation, you just combine the two equations on the top, right?
Yes.
Okay.
Let me do a parallel, because there's been some confusion in the past when I've done that. I don't think I need this anymore. If I have A plus B is equal to 5, and B minus A is equal to 7.
If you just do.
If I just add the equations, on the left-hand side, I have A plus B minus A. Just, I do that plus that. Then add the right-hand sides. A's cancel out.
And then 2B equals 12, and then B equals 6.
So B is 6, that's a 12 there. B equals 6, A is -1. And so all I did was just got rid of those when I wrote the next equation. I just went from here to here.
Okay, thank you.
That's what I was.
Okay, so you just did that to cancel out the The force of tension,
Yeah.
okay. Alright.
I was doing a math problem for practice one day, and I was thinking of something, and cause the number, they had like terms like that, and it was big equations. And that's what I was trying to figure out, like trying to remember to do, but I couldn't like get it out of my head.
And just recognize also that if this had been 2A here, I could have just multiplied the top equation by 2. And then added, and the 2A's would then cancel out.
Oh, okay.
That is a beautiful marker. I had a student a number of years ago who was hypersensitive to the smell. And if I did something like that, she would have had to leave the room.
Oh,
Like she could smell it from like
Oh.
her chair.
Oh, yeah.
My
That's
mom has
insane.
that like hypersensitivity in her nose. Like she'll walk into something and we in our old house we were in like actually multiple times of mold disasters, and that just messed up her neurological response system where like she's really hypersensitive to smells, and so she will walk into like someone's house and be like, I smell mold. And it's like the person went to someone's house who had mold in their basement. Like, and she'll smell it off their clothes. It's pretty crazy.
Not blessing and a curse.
It's more of a curse.
Okay. Any questions on this just absolutely spectacular problem that we have just finished?
I have a question about the girl with the marker.
Oh, yes.
So how did you do class if you open a marker and she had to leave? She just never.
Well, there's a certain amount of, that marker that I just opened up, which smells worse than the others, those were I put off to the side. And there was a certain amount that she just had to deal with it. I mean,
I was just curious.
That's crazy. It's kind of like supernatural.
all right, oh, BJ.
Because a lot of these questions will be like obvious to us figure out on the last one, is this test gonna be shorter, like shorter in questions, do you think? Or,
I mean, that one's.
I mean, the
Is
last
this gonna
one-
be?
I spent a lot of the time for the last test. I mean, I spent the majority of the time doing the test, so
Yeah.
I feel like these are more intensive questions.
I think what it is more than anything is problems have a lot of steps. Because it was only like 2 or 3 pages, right? It was like
well, they're double-sided though.
What's the question again?
yeah.
They're asking if the next test is gonna have as many questions or just one
Yeah.
big question. Since this is.
I don't know yet. I try not to write the test too far in advance.
I saw one of your tests. It was like the Valentine's Day one where it was like one big question about like 2 people are going down the slide.
Yeah, the warning
That
to
was
me
my
should have been, as soon as I wrote the complicated problem, that should have told me that that was just a horrible problem. That, there's a mistake in there, so.
I want you to know that I shared that with my mom. She really appreciated the story.
Okay, good.
She says that you could have been a writer.
Yeah, actually, my favorite tests are the ones that have a story with them, but not every student appreciates the stories I write.
It was appreciated.
There's one about like an F1 car driver or something.
Yeah, that problem only took us an hour and a half, so yeah.
So that means it's taking all of us.
problems, I see, I see.
But do recognize part of it was trying to deal with the board.
Yeah.
You know, that,
I mean,
Alright.
okay.
let's take a break. Oh, sorry.
I hate to bring it back up because I know you've gone over it so many times, but I'm still not really recognizing, what numbers I'm supposed to compare to decide if I need to swap to kinetic friction, or kinetic
Alright.
instead of static.
On just a simple ramp problem.
Sorry.
And hopefully I'll pick numbers that work nicely.
Oh, no.
Oh.
Oh,
This has to be a joke.
Good lord.
There we go.
Let's
Alright. Let's, make it 50 kilograms. No, it's actually good. 15 kilograms, G is 10 meters per second squared. Make that 37-degree angle, so I get a 3, 4, 5 triangle. We'll make use of S, 0.8, use of K, 0.1. So what's the acceleration of the ball? Force diagram, I have weight acting down,
Yeah.
normal force acting this way, and I know friction's gonna be acting up the ramp.
Is that 39 degrees or 30?
37.
37.
37.
Okay.
I know that if it's gonna accelerate, it's gonna accelerate down the ramp, so I'm gonna establish my coordinate system as such. J hat, whether it points in the direction of Y or opposite direction of Y, completely does not matter. But the way I've chosen my I hat there, I know that a positive acceleration is expected. If it is gonna be accelerating down the ramp, it'll be a positive number. I decompose. This will be W cosine of theta and W sine of theta, Y and friction. If it starts at rest, I first need to establish, is it going to overcome the static friction? So I assume to start out with static. That could be wrong, but that's just my starting assumption. I get W sine theta minus the friction is equal to mass times acceleration. And Y minus W cosine theta is equal to 0. And again, if you chose the J hat to be in the opposite direction, then you'd have W cosine theta minus Y equals 0. Substitution. So for this equation, I have mg sine theta minus mu s y is equal to mass times acceleration. And here, y, I'm going to go ahead and add that as I do this, is equal to mg cosine theta. So all just following it, we don't know whether it's going to overcome or not in theory, although some of you might have a gut feeling.
I think it's gonna overcome.
You think what?
I think it's gonna overcome.
All right. I now need to solve, I'm trying to solve for acceleration. So I take my value, my formula for y in this case, and then plug it in. And so I have mg sine theta minus mu s mg cosine theta is equal to ma. This is just my normal force.
Right.
And then what is G, 10?
Yeah.
Okay.
Oh, we already established that.
So I have 150 times the sine of 37 degrees, which is about 0.6, minus 0.8 times 150 times the cosine, which is 0.8, is equal to ma.
You can just go ahead and divide it by the mass.
Okay.
Call it that.
That's, apparently I did that as we went. No, I didn't.
No, we didn't.
I never, oh, I did give a mass. So actually, if I just do that, then,
And then just make it 10, right?
yeah. That's it.
Right.
That makes life simple. So I get 6 minus 6.4 is equal to A. A is negative 0.4. Wait,
So we have negative acceleration. Oh, so
That
we
means
didn't
it's holding
overcome.
So it's-
because if it's going to accelerate, I know it's going to accelerate down the ramp.
Right.
That negative tells me if this is physically what's happening, if that is truly the acceleration, that means it's accelerating up the ramp. And I think we know from experience that if you put something on a ramp It's not gonna mysteriously start moving one direction.
So what does that mean?
So therefore, we have not overcome static friction.
And then kinetic friction is involved, and you just replace use of S with use of K, don't you?
If it's not accelerating, if we have not overcome static friction, then my acceleration is 0.
Right. Meaning that that's actually mu sub s. Oh, it was mu sub s 3.
We assume, so we go out and we start with, let's assume maximum, because if it's gonna start sliding, it has to overcome the maximum friction, static friction. So we go stick that in there, we get a negative saying it did not overcome the maximum static, therefore acceleration is 0.
Right.
If we've gotten a positive answer here, that means, oh, it did overcome it. Now we plug K, use of K in.
Okay.
Okay.
So you're saying that if we get a negative acceleration, does that mean the box is not moving?
That means if it is moving, it's moving in the negative direction, which would be up the ramp, which
That
just
doesn't
does
make
not make
sense.
Okay.
From a physics point of view, we do have physical, there are certain things that limit us. It's not like a math class where you can get a negative there and go, oh, sure, why not?
So it is static then?
In this case, we don't need to plug in kinetic.
No,
Thank you.
because it didn't overgo. Oh, that makes sense.
Let's see.
But if we got a positive acceleration, we would have to plug in mu sub K.
Right.
Yes.
Okay.
So if this had been 0.7, then this becomes 5.6. It's positive 0.4. Now we know that it is going to actually move. So we put in use of K, and this becomes 0.8.
0.8 now?
Is that why, I think you may have mentioned once before that the value of the kinetic is always gonna be higher or bigger than static?
UK is always smaller. than-
Smaller, okay.
Smaller.
Okay.
That's like the most quick and dirty explanation of that I've ever seen.
Yeah.
Yeah, it made like complete sense.
Now, I will tell you, as a student, I hated think about the problem we just did. If I just given that as is and said, you know, none of the warm up to it, I just gave you the problem and just said, here's my 2 angles. What's the acceleration? Properly,